With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is, a monatomic gas is expanded adiabatically and due to expansion of volume becomes 8 times. Volume became 8 times, then we have to choose the correct option. And the options are, we can see, this first option, pressure becomes 1 by 32 times, and the option we can see, kinetic energy of the gas molecules becomes this 1 by 4 times. And the C option we can see, ratio of translational and rotational kinetic energy changes with variation of temperature. Clear this. And the D option, none of which. Now it is given that the monoatomic gas. So as we know, this is what process is what expansion is adiabatically. So for this we know P and V to the power gamma, and this is equal to constant. Clear? And this is what monoatomic. For the monoatomic, gamma is equal to 5 by 3. For monoatomic, we can write this gamma is equal to 5 by 3. So if you put value, so this is equal to, we can write P V to the power 5 by 3 is equal to constant. Now it is given that the volume becomes 8 times. So from here we can write P1 V1 to the power 5 by 3 is equal to, we can write P2 and V to the power, we can write 5 by 3. This. Now from here we can see that this P1 and V1, and this V2 is given, that is equal to 8 into V1. This V2 is given, that is equal to 8 into V1. Clear? So if you put this value here, so this is equal to P1 V1 to the power 5 by 3 is equal to, we can write P2 and 8 into V1, and to the power we can write 5 by 3. This. Now from here we can write P1 V1 to the power 5 by 3 is equal to, we can write this is the P2, and we can write this is equal to 8 to the power 5 by 3, and V1 to the power we can write 5 by 3. So from here we can say this V1 to the power 5 by 3 and V1 to the power 5 by 3 cancel out to each other. Now here we can write P1 is equal to P2, and we can solve this a to the power 5 by 2, and this is equal to 32. Now from here we can write P2 is equal to P1 and divided by 32. This, and this can be written as, from here we can write P2 is equal to 1 by 32 into P1. Clear? Now we can see that this P2 is equal to, final pressure is equal to 1 by this 32 times of P1. Now coming to this options, pressure becomes 1 by 32 times. Yes. So this is the correct option. Okay. Now coming to the second, total kinetic energy molecules becomes 1 by 4 times. So kinetic energy, for kinetic energy we have to find the temperature. Temperature, because kinetic energy equal to, we know this is equal to 3 by 2 nR and T. So temperature we have to find. So first of all we have to find the relation of the temperature. So as we know, P and V is equal to nRT. nRT. This. Now from here we can write this. So PV equal to nRT. So we can write P1 V1 is equal to nR into this T1. This. Now we can write P2 V2 is equal to nR, and T2 we can write. Let us consider this the first equation, and this is what second equation. So if we divide first equation by second equation, then we will get this is the P1 V1, and divided by, we can write P2 V2 is equal to, we can write T1 and divide by this T2. Clear? Now we can find the relation between this T1 and T2. So from here we can write P1 V1. So P1 V1 and divide by P2 is what? 1 by 32 into P1. Clear? And V1 V2 is what? 8 into V1. So 8 into V1 we can put, and this is equal to T1 and divide by this T2. Clear? Now from here we can write this is equal to this P1 and P1 cancel out. So we can write this is equal to this 1 by 4. So we can write 4 divided by 1 is equal to, because 8 4 is 32. So this 4, and we can write 4 by 1 is equal to this T1 and divide by T2. We can write. Clear? Now from here we can see that this T2 is equal to 1 by 4 of T1. This. Clear? Now we have to find the kinetic energy. So for kinetic energy we can use, and this kinetic energy directly proportional to temperature. So for kinetic energy is equal to 3 by 2 N and R into T. Clear? So initial kinetic energy, what? Initial kinetic energy 1 is equal to, we can write 3 by 2 N R and T1 we can write, and kinetic energy 2 we can write this is equal to 3 by 2 N R into T2 we can write, and T2 is equal to what? 1 by 4 into T1. So we can write in this way, 1 by 4 into T1. Now if we divide this equation, let us consider this is the third equation and this is what? Fourth equation. So if we divide third by 4, then we will get kinetic energy 1 initial and divide by kinetic energy we can write 2, and this is equal to, we can see from here, this is the 4 and divided by 1. Clear? Now from here we can see that this kinetic energy this final is equal to 1 by 4 of kinetic energy this initial. Clear? Kinetic energy 2 we can write, kinetic energy 2 and 1. So here we can write kinetic energy 2 is equal to 1 by 4. So we can see that this second option is the also correct. Clear? So this is the also correct. We get total kinetic energy of the molecules becomes 1 by 4 times. So this is also correct. Now coming to this, a ratio of translational and the rotational kinetic energy changes with variation of temperature. So this is the incorrect. Why this is the incorrect? So when the temperature will change, then what will happen? Translational and the rotational kinetic energy both will change, due to which the ratio will constant. But here it is given that a ratio of translational and the rotational kinetic energy changes. So we can say that this is the incorrect option. Clear? Now we can see that according to the questions, A and B is the correct option for this question. Hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.